In this question, we will find out the maximum coefficient of static friction means mu s equation about this situation in which you can see a block is placed on the ramp and that is not frictionless. So, and what we are doing in this question, we are increasing this angle. And as we are increasing the angle, something is going to change, which I will show you with the help of different diagrams. So let's draw a ramp at a very small angle on which the block is placed, and when we will increase our angle, what will happen? I will tell you with the help of the diagram, and you see I'm increasing the angle. So student, you can see that the same block but on the same ramp but with a different angle. Actually, on this ramp there is a very small amount of force, which is basically mg sine theta, which is trying to push the block downward. And when you are increasing angle, what is happening? This amount of force is increasing. So at this certain angle, this block is about to slide on it. Okay, so of course at this mg sine theta will have a larger value. So in this question they are saying that the angle, the theta is adjusted until the block is just at the point of sliding, means it is still at rest but it is about to slide. So what will be the value of coefficient of static friction? So I will explain you with the help of free body diagram. Right now I'm going to show you its free body diagram. So for this ramp, our rectangular coordinate system will be like this. It will be also tilted by the same angle. So let's say like this is our x-axis and this is our positive y-axis, and we imagine that this is a block. How many forces are exerted on it? So obviously the one force that will be vertically downward must be the weight of the block. Okay, so that is, let's say, mg. Okay, and this is an angle, that the same angle as this one which we had increased. Okay, right now there is another force exerted on it by the ramp. Okay, and you know very well that this force must be the normal force, and this force, okay, this force will be equal to the one component of the force. But since it's a free body diagram, I will first show you all the forces exerted on it. Since this block can slide in this direction, that's why the force of friction must be in the opposite direction, something like this. Okay, so this is a force of friction, which is which force? It's a mu s fn. It's the maximum force exerted on this block right now, which is preventing any kind of sliding. Now students, we will make the components of the force. So if I make the component, so this is a one component, that is the adjacent component, that is mg cos theta, whereas the other component will be on the x-axis. We can call it x component, which is actually this one. This must be mg sine theta. So students, if this block is not sliding or it is just about to slide, it means that the forces along the x-axis, if you see, the one force is a frictional force and the other force is the one component of the force must be equal to each other. All right, so when we will make equation, since we can call it is it, don't you think this is an equilibrium? So fg mg sine theta is our first equation, whereas you know that the force of friction is mu s normal force is equals to mg sine theta, and I told you that the forces along y-axis are balancing each other. That's why we can put the value of the normal force, which is mg cos of theta, is equals to mg sine theta. We can cancel this mg on the both sides, and from here the coefficient of static friction must be equals to tan theta. So the right answer should be C.